All right, good morning. I guess by the clock on the wall, it's time to start. Last week class, we ended, when we ended, we were discussing NASA's DART mission. And just to remind you, the DART stands for Double Asteroid Redirection Test. And this was the purpose of this was to be able to test the viability of going out and striking an asteroid and redirecting its trajectory, and thus hopefully having the ability to deflect any potential asteroid that might strike the Earth and cause damage here away from the Earth. So this hopefully to avoid a catastrophic or impact to the Earth. And for this test, they selected an asteroid named Dimorphos. And this is an asteroid that's around 525 feet in diameter, and its trajectory is expected to pass within about 800 miles of the Earth in October of the year 2184. And so this asteroid is actually in orbit around a larger asteroid named Didymos. And so they wanted to impact this Dimorphos to change its orbital speed, to change its orbital path around the larger asteroid. And so they did this by sacrificing basically a spacecraft that slammed into this asteroid at a speed of around 15,000 miles an hour. And this impact occurred on September 26th of 2022. But the results, as we talked about last week, of this impact were not what NASA had expected. They were expecting to impact a solid object, a solid rock. In actuality, they actually impacted a flying rock pile, which basically is a pile of rock made up of much smaller rocks and boulders held together loosely by ice, basically acting kind of as a glue to hold it all together. And we showed a photo of this last week of an image of this impact just after it happened, showing a bunch of boulders that are being scattered out now away from this asteroid. Not at all what they expected. And so a camera was ejected out of the spacecraft about 15 days before it impacted Dimorphos in order to be able to film this. And so on NASA's website, they have something called the Astronomical Picture of the Day, or APOD, APOD for short. And on their entry from October 5th of 2022, they commented about this impact and the plume that occurred after this impact. And again, it's not at all what they expected. So we talked a bit about some physical properties, like if you were to use a cue ball and you were to strike a rack of balls, like in a triangle, like you play in a game of billiards, the cue ball would hit the head ball, and then energy would be transferred from one ball to another in this rack, and then the balls at the far side basically would explode out. Well, that's what happened basically with this impact. So since all these rocks inside this asteroid were touching each other for the most part, what we saw now was a plume of rocks and debris that headed out away from this asteroid. This is, again, not at all what they thought it was going to be. And here on the screen here, we see a picture taken from Earth from the Atlas project of showing this trail now of debris coming out from the back of this asteroid that was struck. And so it gave us a debris tail that's thousands of miles long. And so on October 11th of 2022, which is just about 2 weeks after this impact occurred, NASA declared that DART was a success. And the original intent of this was to alter the orbit of Dimorphos around Didymos, and they confirmed that they had shortened the orbital period by about 33 minutes. Now, they expected it to be about 73 seconds. So the orbital period of time from Dimorphos around Didymos was 11 hours and 55 minutes before the impact, and then after the impact it was shortened to 11 hours and 22 minutes, which is a total decrease of 23 minutes and 15 seconds. This change in time was quite a bit different than what they expected. That's again because this asteroid was not composed of the solid rock that they thought it was going to be. Instead, it was composed of individual rocks and dust and dirt and debris, something again that was predicted and confirmed by hydroplate theory. So NASA considered this a success. So was it a success after all? So last week I showed you an email that Kevin Lee who's one of the leading advocates for hydroplate theory, had sent to NASA on the day after the impact. And this was before any of the images of this impact from this camera were released. So he made predictions specifically about what they were going to find based on what we would expect on how these comets and asteroids and these objects would have been composed of, what they would have been composed of. And so he now sends another email to NASA on March 27th of 2023. Now this is about 6 months now after the DART impact. And in this key email he writes, questions related to DART. There has been very little news about the DART mission since impact. I kind of wonder why. Why, if this was a big success, wouldn't you be kind of guessing that NASA would be kind of touting this and making a kind of a big deal about this? But curiously, there's very little news about it, and they haven't said much about it. This is 6 months after this impact occurred. So Kevin continues on saying, I'm wondering about the following. Question 1, these are a series of questions he now starts to ask. If success was expected to be a change in the Dimorphos orbital period by 73 seconds, why was it 32 minutes instead? It was actually 33 minutes and 15 seconds. But he says, am I wrong to think that this must mean that the density mass of Dimorphos must have been about that much less than expected? So in other words, they expected to hit a solid rock. They didn't. He goes on to say this is a 26 times more of a change than expected. So how did they miss it by that much? Am I wrong to think that it must mean that the mass density of Dimorphos must have been about that much less than expected? I know that the French are sending another probe in 2024 to accurately measure the density of Dimorphos, but how are we so far off? To me, it looks like impacting asteroids is a bit of a dangerous game and that you might not get the results you expect. So imagine now playing a game of billiards. We use the billiard balls as kind of a good analogy of this. Now imagine playing a billiard ball game of pool where all your balls you're striking are of totally different masses. Maybe you got a ping pong ball in there with a steel ball, or a completely different construction. It will become now, when you hit the rack of balls during the break, it would be very difficult to predict now what the outcome is going to be. I mean, of course, the outcome would be what would happen according to the laws of physics and motion, but it's just that an arrangement like that of a flying rock pile like this would be so complex that you wouldn't be able to anticipate it. You wouldn't be able to accurately anticipate what would have happened. So I suppose what we learned is that the asteroid's deflection is a lot more complex and more complicated than NASA had anticipated. And so what Kevin is referring to here in this other mission by the French is that there's a mission called Hera, which is from the European Space Agency. They launched this mission in October of 2024 and expected to reach Dimorphos and Didymos in late 2026, late this year. So it's a mission going out to take high-resolution pictures of the impact crater that occurred because of this impact. And I think this will be very interesting to see what these pictures send back to us. This will be very high-resolution pictures. So I'm kind of waiting, anxiously, of course, to see what these look like. So he goes on, question 2, it appears from the amount of ejecta that was accelerated away from Dimorphos that it must have been more of a rock pile instead of an asteroid than what mission planners were expecting. How could a pile of rocks come together to form Dimorphos, this asteroid? Of course, evolutionary theory cannot explain this. The formation of the solar system out of a swirling dust cloud, which is what is commonly taught today as where our solar system came from, can't explain this. A dust cloud would not have produced what we see, and we'll talk a little bit about that as well. But the current secular speculation of how the solar system formed is that, hey, it was this swirling cloud of gas that somehow coalesced and came together. And there's many reasons why that doesn't make any sense. But he goes on to say, it looked like Didymos also had a rock pile surface when the DART camera was flying by. If you remember the video we showed, the closer you got, the more resolution you started to see, and you started to see there's all these rocks. They're individual rocks on the surface of this asteroid. So the more complete question is, how could a binary asteroid, in other words, one where you have two, you have one orbiting the other, how could a binary asteroid form out of rock piles? How would these form in the first place, then how would one end go into orbit around the other one? There's all these questions that puzzle them. The secular astronomers don't have a way to explain this. But these can be easily explained by hydroplate theory, by processes we've talked about. So this is, again, the ability for this theory to be able to accurately predict in the future what they're going to find shows how powerful this is and shows how accurate I think that it is. And then for question 3, it says, for a while there was a comet tail appearance in the ejecta. What was learned from the light spectrometry? And then question 4 was there water vapor released by the impact, which contributed to the comet-like appearance? As we saw a couple slides back, it is kind of now a tail. It looks kind of more like a comet. If so, how did water and rocks come together to form this asteroid? Again, no answers to these questions. And he continues on with question after question, which I'm assuming that NASA doesn't really want to answer. I mean, they don't really want to have these kind of questions posed to them. So question 5 is what was the calculated amount of ejecta in cubic meters or mass that left amorphous? Question 6, has anyone done an analysis on the orbital paths that the ejecta has taken? This is a key question right here. And is it possible, because it leads into this question, that someday Earth will be having a DART meteor shower? These are all great questions, of course, and remember that these questions come right after the impact, before the images of the impact or details of the impact were made available to the public. And it's incredibly important to realize that these questions come from a major proponent of hydroplate theory based on what hydroplate theory predicts how asteroids are composed. So Dr. Brown again made predictions about asteroids' composition well before they were discovered to be these piles of rock. So regarding question 7, which asks, is it possible that someday Earth will have a DART meteor shower? Remember that prior to the impact of Dimorphos, these 2 asteroids were only supposed to have passed by the Earth by a distance of around 800 miles. So this happens around 150 years from now. So again, it's far enough away, it's still in the future. Now that's 800 miles is rather close in terms of the great distances that we see in outer space, but it's still, not that far away from Earth. I mean, it could be a potential threat to the Earth. But at this point, when they did this, they didn't think it was going to be a threat to the Earth. They just did this as a test, basically, a test run to see if this was possible. So this Atlas program that was developed to be able to scan the skies and see what was out there and possibly detect these things in enough time to where then now they could react and send something up there to strike it. That's the whole, process, behind what was going on here. And Dr. Brownlee did not respond, but NASA did 5 months later. So again, this guy he sent this email to didn't respond. So I guess why? I wonder why. So regarding question 6, which he asked, has anyone done an analysis of the orbital paths that this ejecta has taken? So I showed this slide last week. I thought I'd just show it again real quick. This shows the expanding debris field that came from this asteroid. So we see Dimorphos here over as the asteroid that was struck, and then you see this field of debris that's spreading out. There's a cluster they call the northeast cluster and one called the south cluster. And I don't know if you can see this very well from this distance, but there's individual boulders that they're now tracking that are circled in yellow. But there's a whole bunch more that they're not tracking. I mean, there's a lot of boulders here. This created quite a debris field that occurred that's now spreading about away from Dimorphos. So now, if you think about this logically, do you think that this debris field would have now a greater probability or possibility of striking the Earth? What would you guess the answer to be? I don't know if we know quite yet, but I'm thinking now this is now spreading apart, and what was predicted really probably not to hit the Earth, now I'm thinking there's a much greater possibility of this now hitting the Earth. And that may be the reason that NASA doesn't want to talk about this. So apparently this is now a concern that NASA now admits to. Around 5 months later than Kevin's second email to NASA, NASA now admits that DART created a potential hazard to the Earth. So a guy named Kevin Hughes in Natural News in August 11th of 2023 reported the following. He says, NASA asteroid deflection test, or DART, accidentally created a boulder storm that could impact the Earth with as much energy as the Hiroshima detonation, the atomic bomb that was used in World War II. The asteroid was struck by the spacecraft in September of 2022. Then nearly a year later, this statement was released by NASA. So the fact that this emission comes close to a year later appears to me that they didn't really want to admit this at first. But I think that now that they're forced to admit it, I mean, there's enough evidence now that they can't deny it. You know, they found that this is, I think, a very real possibility. So they had the images from the camera that filmed this impact. They started circling individual boulders. They knew about this. I mean, they started, at least it certainly seems that way to me, that they even started to track these things right away. So again, this impact produced results that were much different than what they expected. And then they go on to say, but astronomers have now discovered that even though the impact succeeded, yes, they certainly successfully hit this asteroid, it also removed 37 boulders from Dimorphos, which are now zooming through space at a speed of around 13,000 miles an hour. These boulders were identified by the Hubble Space Telescope and range in size from 3 to 22 feet across. And so these space rocks are drifting away from Dimorphos at a speed of a little more than a half a mile per hour. In conclusion, they said, scientists have discovered that the NASA, National Aeronautics and Space Administration, NASA, accidentally released a storm of boulders as deadly as Hiroshima while they were testing to see if this trajectory could have been changed. So they accidentally did this. You know, the year 2184 is when Didymos and Dimorphos were expected to pass by Earth. You know, that's quite a while from now, and I suspect those that are living at that time, you know, will be well aware of this before it happens, and hopefully there's enough time for them to be able to deal with this problem, you know, before the year 2184 comes. But I'm thinking, given technology, you know, hopefully they'll be able to develop a good solution for this potential problem. But so the good news from all this is that we actually can send out a spacecraft at extremely far distances and strike an asteroid. The bad news is that NASA doesn't really know what they're doing, since they're making assumptions about these asteroids that are based on their evolutionary perspective. In other words, they feel that these were solid rock. And perhaps if they read hydroplate theory, they would understand why they are made up of rock piles. And they would have discovered what they did could have had potential consequences like this. And if that was the case, they probably wouldn't have done this in the first place, and hopefully might have avoided a potential future disaster. So now, the next section here, I wanted to go into trans-Neptunian objects, which are called TNOs for short. And I don't spending a lot of time on this, but there are some interesting aspects of TNOs too that I think we want to talk about. So we spent time on comets and asteroids. But a trans-Neptunian object is similar, very similar to an asteroid, and because it formed in very similar ways. But a trans-Neptunian object is defined as any minor planet orbiting the sun at a greater average distance than Neptune. So Neptune is currently considered to be the furthest planet out. Now Pluto, there's a controversy about whether Pluto's a planet or not. So I'm not going to worry too much about that here. But at the distance of Neptune, this is around 30.1 astronomical units from the sun. So that's, again, the astronomical unit is the distance from the sun to the Earth. So Neptune's 30 times further away. It's 30 times out there. And these TNOs were discovered in 1992. And they've discovered there's at least 70,000 of them with diameters larger than 60 miles in diameter, and some of them are up to 1,500 miles in diameter. These much bigger than normal asteroids are. And they're found at 30 to 50 astronomical units from the sun in a region called the Kuiper belt. So Neptune, again, is 30.1. These are now at and beyond Neptune, up to around 20 astronomical units further beyond Neptune. That's pretty incredible here. And they've also discovered that the total mass, or estimated the total mass of all the TNOs would be about 3% of the total mass of the Earth itself. So plus or minus a percent. So it could be 2% or maybe a little bit more than 3%, but they don't really know. We can't really tell. But as we discussed earlier, asteroids are flying rock piles, and this has been confirmed, and they have less mass than was assumed because they're made up of lots of space inside of them, and there's ice, water holding them together. Same thing holds true for TNOs. So in order, again, for asteroids to form, a newly budding asteroid must capture not just a few rocks to coalesce, because of special circumstances, being ejected out of the fountains of the great deep, traveling at the same rate of speed, the same direction. Their small gravitational forces would allow them now to accrete together to form these asteroids and form comets. TNOs formed in the same basic way, but there's something a little bit different about them that we'll talk about here. So again, special circumstances are necessary for these things to form. Again, evolutionary theory doesn't have any process that can explain this. Out in outer space, things should move away from each other. They shouldn't come together, especially with the extremely small gravitational forces that would be on individual rocks. They would tend to move away from each other rather than coming together. And if it was the case that our solar system formed out of a swirling dust cloud, this dust can explain the formation of the asteroids. And it would be even now a greater task to explain the formation of a TNO, because they're extremely further away and they're larger. And the density of the TNOs basically have been determined to be unusually light and similar to the composition of the asteroids. And we would expect this because of hydroplate theory, because they kind of form the same way out of the same processes. So what's also surprising is that many of these TNOs are what are termed contact binaries. So these are two bodies that had once orbited each other but are now in permanent contact with each other, such as the one you see here on the screen. So this one was named 486958 Orokath. Really interesting name, right? But individually, these objects were named Ultima and Thule. So they gave names to each of these individuals, even though they're now permanently contacting each other. And this photo was taken on New Year's Day in 2019 by NASA's Horizon spacecraft, when it was 4 billion miles from the Earth, making it the most distant and technically challenging exploration ever made by man. This unusual formation of contact binaries are like spinning dumbbells in outer space. So they're two massive weights joined together by a very short rod. And from what we talked about a few weeks ago with the formation of asteroids, I think we have a reason, a process for how this could happen. Remember how we talked about some asteroids were peanut-shaped or rubber ducky-shaped? There were special circumstances in these asteroids that allowed them to come together slowly and merge together, forming these unusual formations. It's hard to imagine how this occurred randomly. So there's no gaseous atmosphere out here to provide the slowing down of these two bodies where they wouldn't slam into each other and just basically explode. They very slowly would have come together, and based on what we see with what would be predicted by hydroplate theory. So again, if they were to collide with much force at all, they would shatter and disperse in many different directions. And that's because they're very loosely held together by low amounts of gravity and ice. And so we'll see that TNOs would have formed by the same processes that produce comets and asteroids. And then we'll, in just a minute here, discuss how they got so far out there. So special circumstances did that. So thinking about how TNOs could have formed out in that process out there in the Kuiper belt, it's something, again, that just not really explained at all by evolutionary theory. So NASA's website has a page regarding this contact binary TNO that was the merging of these two asteroids. Again, they were named Ultima and Thule. And the flyby results were featured on the cover of Science magazine's May 17th, 2019 edition. And the NASA page about this stated that this object in the Kuiper belt, they said this, the initial data summarized in Science reveal much about the object's development, geology, and composition. It's a contact binary with two distinctly different shaped lobes. Okay, so you're saying it reveals a lot about the object's development and composition. How? You know, you've made incorrect guesses about everything else. So they go on to say this, it's about 22 miles long. The Ultima Thule binary consists of a large, strangely flat lobe, nicknamed Ultima, connected to a smaller, somewhat rounder lobe, nicknamed Thule, at a juncture called, or nicknamed the neck. So how these two lobes got their unusual shape is an unanticipated mystery that likely relates to how they were formed billions of years ago. Again, all these fuzzy words, okay, it's an unanticipated mystery. It's a mystery to them. They don't know. They say they know, but how can they make statements like this? That likely, again, no solid evidence that this happened. It's likely that this happened. So how do they know this? So if you remember that earlier comment about this contact binary in the previous slide, it says the initial data summarized in Science reveals a lot about the object's development in geology and composition. However, in the article they go on to state that it's a mystery to them. What are they saying? I mean, it's either they know how it formed, and they have scientifically based principles that would allow these things to have formed, or they don't. You know, going again, of course, they assume that they formed billions of years ago, but without describing a viable mechanism, not only for their unusual shapes, but how they could have formed in the first place, and then how they came into permanent contact with each other. I mean, again, they just don't have the answers for this, you know, so. Question?
Quick question.
Yeah.
I mean, you know, how they had talked about the two lobes that came together, but is that color truly what they had?
I think it is. Yeah, I'm not positive. I think it's a true color on
I mean,
that.
because it just kind of makes you wonder, where from Earth did it possibly come from?
Well, we see a mixture of things. Yeah. And remember, we saw these unusual features on all these asteroids. You know, they go out and they send these missions out and they collect samples and bring them back, and they're finding, you know, just what you find on Earth, exactly the same materials. They're finding, you know, organic matter, you know, fragments of DNA, the nucleotides of DNA. They're finding bacteria, you know, they're finding, you know, amino acids, you know. It's a far cry from life, but I mean, these are the building blocks of life. You know, this makes them think, oh, life came from outer space. You know, it's like, oh well. Anyway, so once again, these special circumstances that formed these things are readily explained by hydroplate theory and the bursting forth of the great deep. So let's understand how TNOs might have got out where they were, but to kind of do that, we have to look on first at how the asteroid belt originated, and then how TNOs would become located much further out. So the asteroid belt is between Mars and Jupiter, but that's only 5 or so astronomical units out. Neptune's 30. So these things went tremendously further out. So there's something else going on here. So this image here is a polar or top view of our solar system, like you're looking down on top of it. And the cluster of white dots you see here represent the asteroid belt. So these are asteroids out in the asteroid belt. And so this is between Mars and Jupiter. And of course, Mars is the 4th planet from the sun. Jupiter's the 5th, and Earth, of course, is the 3rd planet from the sun. And there's also 3 other clusters of asteroids as well. One called the Greeks, one called Hildas, and one called Trojans. I'm not going to get into that. I just don't really need to spend time on that. But these are also in these orbits around these areas here. So again, certainly some special attributes to some of these that will put them into these places in orbit, just outside of the normal asteroid belt. So why are most asteroids in orbit around the asteroid belt in this area? So from scientifically sound processes, we can see how the effects of the sun would have pushed many of these asteroids from their present orbits outward into this area where is now the asteroid belt. So this is explained how sunlight basically warms the face of the asteroid that is facing the sun, and it creates a much hotter face on that side. And the far side of the asteroid that faces away from the sun, therefore, is much colder. And there's a large temperature difference between the two opposite sides of the asteroid. So the hot gas molecules that hit the hot side of the asteroid that faces the sun will bounce off with more force and velocity and momentum than the opposite cold side. And this difference now slowly expands their orbit out into a point where factors would have dissipated somewhat in the amount of this force, and they would have ended up then in a stable orbit between Mars and Jupiter. So the initial orbits prior to the formation of the asteroid belt would have been elliptical orbits that then gradually expanded out and became circular orbits as these forces acted. So I want to show an animation of this. You have to kind of watch this carefully. You'll see a red line that starts at the Earth. So this is the Earth here in blue with a white circle around it. And you'll see a red line that comes out and basically gives you a trajectory of what would have been expected of these orbits. It starts out as an elliptical orbit, and then gradually, as time goes by, it starts to expand out and become more elliptical. Again, this is all based on known scientific principles. This isn't just a guesswork. This is, I mean, there's principles. Dr. Brown gets into this very deeply in the book. And so those who are, want that kind of information, see the book. I mean, it's too much to go into in a class. But what I want you to see here is, what would be expected. So let's watch this animation as this happens. So gradually expands out and out and out, and then eventually gets into this elliptical orbit range here where the asteroid belt is. So some asteroids do have elliptical orbits rather than circular orbits, kind of more like comets, like we talked about Didymos and Dimorphos. And there's a number of others that will bring them back into orbit that could potentially cross Earth's orbital path, again, given the potential of them striking the Earth at some point in the future. But a lot of them most of them actually ended up in the asteroid belt here. So if the individual trajectories and masses of these objects worked on each other independently, and so some of them would have ended up in several different potential orbital patterns based on these factors. And remember, there's kind of a continuum between comets and asteroids. I mean, they form the same way, and some comets, are kind of asteroid-like, and some asteroids have characteristics of comets. And there's also a debris field we see here that would have formed from the debris ejected from the fountains of the Great Deep that did not accrete into asteroids. And you'll see that in this image here. It's kind of this white hazy area here. So this is a debris field made up of small particles and dust. So this debris cloud would have been composed of dust particles, and they would have had extremely little gravitational forces associated with them, so they would not have accreted into becoming an asteroid. And over, basically the period of time and the low amount of forces, we would expect that after, only a few, maybe 1,000 years or so, that this would dissipate, which is what it did. So now that debris field has kind of faded away, that cloud. So now that we have just a little bit of an understanding of asteroids and being in the asteroid belt, how did some get all the way out to Neptune and beyond to become TNO? So now I want to expand a view of our solar system out to where now we can see the orbit of Neptune at 30.1 AU. So now we're zooming back out here. Now you see Neptune out here. And the distance that it's out there. It's out there quite a bit further out. So again, at 30.1 AU from the sun. So now we can see where the asteroid belt is in relation to the entire view of the solar system, or at least within Neptune. So how would these objects known as TNOs be expanded out that far beyond Neptune? I mean, it seems kind of difficult to explain this, But when we look at this, we can explain it. So whether an asteroid remained in the asteroid belt or continued to spiral away from the sun was a function of these swarms' initial collective mass, which was determined by the amount of gases that they could potentially collect and retain. So just beyond the asteroid belt, a tipping point was reached which distinguished asteroids from TNOs. Near the sun, smaller swarms, represented here, had a smaller sphere of influence and less gravitational pull. So they collected fewer gases and more easily lost their gases to the sun's rays. And once these smaller swarms lost their gases, they spiraled away from the sun and they lost their what are called solar sails in the solar wind. And that started to have less effect on their trajectory, so that they became locked in the asteroid belt. So these smaller conglomerations of rocks and water would have become these asteroids. However, larger swarms that would have formed, had more mass and greater gravitational spheres of influence, so they were able to attract more surrounding material. So the bigger they got, the bigger they got. So as they had more gravitational forces, they would draw in even more material and become bigger and bigger. So a larger swarm's greater mass meant it was harder for the sun's rays to impart the energy for its gases to reach escape velocities. So these swarms held on to the surrounding gases, and each swarm spiraled further away from the sun. Its gases cooled, so the gas was less likely to escape. So the swarm retained its solar sail and continued to spiral further away. So this is how we now see that these objects could get out that far. So for these larger swarms, the sun's energy could continue to act upon the swarm's still present gas sails and push them slowly further and further away from the sun because of the sun's gigantic amount of energy. So since the time of the flood, these swarms have slowly spiraled out to their present orbits to become the TNOs in what's now termed the Kuiper belt. And hydroplate theory of formation readily explains this. Why many TNOs, like asteroids, have moons, and why some pairs of similar size have actually come to orbit each other in what are called wide binaries. So instead of one orbiting the other, they actually orbit around a point between them. Interesting, how they do this. But this can all be explained. Again, Dr. Brown goes into this in his book. It's quite detailed. I mean, it's too much to get into in a class. But those in here that have an interest, I can direct you to where to find more information about this. So we also observed that TNOs show several other rather baffling features, at least for conventional astronomers. So how could this Kuiper belt have formed so far beyond out what was thought to be the edge of our solar system? The edge of our solar system was thought to be Neptune. Well, now this Kuiper belt's now up to 50 astronomical units, 20 further astronomical units away from Neptune's orbit. Astronomers who have studied TNOs recognize that the Kuiper belt could not have evolved that far away or from a swirling dust cloud, and that they're incorrectly taught that produced our solar system. So again, that's the prevailing paradigm today, is that a swirling gas cloud came together somehow and formed all the planets of our solar system, these asteroids and TNOs and everything that's within our solar system. There's many factors that don't make sense about this. Like there's planets that are completely different composition from each other. If they were from the same source, you'd expect them to be similar, but they're not. You'll see some have orbit or spin one direction, and others spin the other direction. Well, if they all come from the same swirling gas cloud, you expect them all to be spinning the same way. There's many of these have moons. Many of these planets have moons. In fact, there's around 200 moons around different planets in our solar system. And you'd expect the moons to all orbit around the planets that they orbit in the same direction, but they don't. Some of them spin backwards. In fact, some of them have moons that go both directions. So a lot of things are just totally inconsistent. Just don't make sense that the solar system came out of a swirling gas cloud. And there's one more strange item about TNOs and the Kuiper belt that I want to mention before we finish our discussion on TNOs. And this illustration shows a side view of our solar system that shows the sun on the left as this yellow dot here. So this is the sun. Again, this is nowhere near to scale. You just have to kind of go with it here. And then the red X indicates where Earth is. So obviously, at this scale, we're really close to the sun. We're not, but I mean, in this kind of scale we are. And this chart shows where the Kuiper belt is here. And this horizontal line represents the Earth's what's called orbital plane. So the orbital plane is basically directly out from the Earth. And you'll see that all of these are not randomly placed around the orbital plane. And there's 12 special ones here represented by these black dots that are really close. These are special TNOs that are much, much further out even than the Kuiper belt. So again, we talked about the Kuiper belt having about 70,000 TNOs, having a diameter of somewhere between 60 and 150 miles. But these little black dots on the right here have been discovered that are 150 astronomical units from the sun out to one called Sedna, which is the furthest one out from the sun. And it averages at 532 astronomical units. So that's 532 times further away from the sun than the Earth is. So this is an orbit around the sun. And Sedna, even more amazingly, is an elliptical type orbit. And it can go out to be as much as over 900 astronomical units from the sun. I mean, 900 astronomical, that's insane. 900 times further out. So this is basically telling us this is how far out the sun's gravitational influence goes. I mean, if it's stayed orbiting the sun, it's captured by sun's gravity. That's how far out. And maybe even further than that, but I mean, that's as far out. It tells you how massive that amount of gravitational influence is. But they're captured around the sun, sun's influence of gravity. And so Sedna, even Sedna should be considered to be part of our solar system because it still orbits the sun here. And but the extreme closeness of these 12 around the orbital plane, being that close, can't be a coincidence. I mean, this can't be something that happens randomly. There had to be something that explains this. It can't be by chance alone. So if the solar system truly evolved out of a swirling dust cloud, you'd expect these extreme TNOs to be, I don't think they'd be clustered this close to Earth's orbital plane. However, hydroplate theory predicts this because they were all ejected from the Earth at the same time. And then, again, there's this extreme distance of Sedna. So Mike Brown, who was a leader in discovering TNOs, he made this remark when learning about Sedna's extreme location so far out from the sun. He said, there's nothing in our solar system today that can put Sedna in this orbit. Sedna just blew our minds. There had to be something different about the solar system in the past. Yeah, I think there was something different in the past than what you believe. I mean, where did conventional astronomers go wrong here? Their swirling dust cloud is a fiction. And believing in billions and millions of years allows them to imagine and promote hypotheses that can't be tested. And the general public has really heard very little about TNOs because it's so perplexing to astronomers. Another discoverer of TNOs named Scott Shepard had this to say. He says, these objects couldn't get out there with what we currently know. So what do they not currently know? The consequences of the earth-shaking catastrophic global flood that readily explains these strange features gives us an explanation for this that they don't have an explanation for. Perhaps if they read hydroplate theory, that would blow their minds. I mean, if they want their minds blown, that's what they need to read. And we see this over and over and over again of all these strange, unusual, crazy features that they don't have an answer for, and we'll see this in coming classes here as we move on. There's all these unusual, strange features of the Earth and beyond that puzzle and baffle the conventional scientists, but can easily and scientifically be explained as a result of a global flood. Thank you. We'll see you next week.